Let us discuss about the priority encoders, how to design a priority encoder. So lastly, we have seen that when more than one input is high, the output of the encoder will not be able to give the correct output. So that is the reason why we are going for the priority encoder. So priority encoder is an encoder circuit that includes the priority function. So here, if you take it out, the operation of the priority encoder is such that if two or more lines are inputs are equal to one, that is, it is considered as high. At the same time, the input which is having the highest priority will take precedence. So the output V is a valid bit indicator. If it is equal to 1 when one or more inputs are 1, it is equal to 0 when there is no valid output, uh, valid input. So you can take up the inputs like this and you have the output X and Y, which is, and then valid bit indicator. So you have 0, 0, 0, 0. We don't care about it. And the V is also 0. Now, if you take D naught as 1, all the other three inputs are 0 means the valid bit indicator is equal to 1. Okay. So, and then X and Y are 0. And then X 1. What is this X means? For example, if D naught is 1, all the other inputs are going to be 0. The next input, if you take it, D1, this is the D, when you compare D naught and D1, D1 is having the highest priority than the D naught. Okay. So that's why we will not consider D naught, whatever may be, we are going to give the preference only to the D1. That's why the 0, 1 you will get it. Similarly, when you consider D naught, D1, D2, which is having the highest priority, D2 is having the highest priority. So that will be set as 1. We are not going to bother about whether D0 is 1 or 0 because D1, D2 is the highest priority. That's why we are not considering the lower order input here. So XXX1 means you will have all the 1 means you will have D3 as high. We will not care about the D0, D1 and D2 input. So higher the priority, the higher the priority of the input. So as I already said, example D3 has the highest priority regardless of the values of the other inputs. If D3 is 1, the output XY will be equal to 1, 1. So that's the thing. We can plot this also. So we can have D0, D1, D2, D3, and you can have the plots like this. Okay. So 0, 0, 0, 0. What is the X value? X only. And then when you take only the X value, X 0, 0, 1, 1. Okay. So we have to consider the don't cares also. Okay. Don't cares also we need to consider here. So for example, if you take 0, 0, then it is going to be D naught is equal to 1, 1, triple 0, you have it. Okay. Like that, if you have X value is 0, again, D3, what is D naught, D1, and then D2, D3. So here I can substitute either 0 or 1. So 0, 1, if I consider 0, it is 1. And the next time I will consider 1, 1 also. So two things have to be mapped over here. Okay. Now if you see that what are all the things we need to take it up? 0, 1 and 1, 1. Okay. So 0, 1 means it is 4. So 4 is plotted as 1 here. Okay, 4 is plotted as 1 here. Like that, you need to take it up. 1 means double 1, double 0. That min term has to be substituted as 1. Like this, it goes on and you can plot it out. And then we can have the, this is 0, 0, you have the don't care condition. That is the thing we have done it. For 1, what are the possible? This is 2 or 0. For a 1, you will have the combination 0, 0, 1, 0 and 0, 1, 1, 0. Then what are the things? 0, 1, this is 0, 0. Next is 0, 1. then 1 0 1 1. So all the combinations you will take up, and in that particular minterm you have to put the, and you have to plot it as 1. Similarly, you have 3x are there. So three possible values you need to take it out, and that minterms you need to substitute it as 1. So when you plot it for x, you get d2 plus d3. When you plot it for y, d3 plus d1, d1, d1 plus d2 dash. So the x and y, similarly for valid input also, valid bit indicator also you made it. And you have to have the circuit diagram. So thank you.